Okay, we're going to talk about an inverse today. The inverse represents the exact opposite set of instructions. So when you think about what is a set of instructions, there's all different kinds of ways to give a set of instructions. For instance, we're at Santa Fe College. I could give you a set of instructions to get downtown. Everyone okay with that? So starting here at Santa Fe College, my set of rules could get you to downtown Gainesville. What would be the inverse of that set of instructions? Exactly. How to go from downtown Gainesville to get back to Santa Fe College. I could give you a set of instructions on how to build a table. So you would start with all the parts, you'd build a table, you're done. The inverse function then would be a set of instructions to dismantle the table. Everyone okay with that idea? So one set of instructions, and its inverse basically simply undoes it. Now, if we imagine that in a very simplistic format, we got some parts, and I'm going to have a set of instructions. I will call that set of instructions the function f. I do something with these set of parts. Let's say I build a chair. So after following the set of instructions, I end up with this chair. Everyone okay with that? The inverse set of operation then, I will for right now call that term G. So again, it's a set of instructions. It should take in, and if I follow that set of instructions, what should I end up with? The parts that I begin with. Notice, I could take those parts and follow the first set of instructions again, and I would build a. And if I follow the second set of instructions again, I would end up with. So it makes a complete circle. I start and end on one function, and the other function does the exact opposite set of rules. I start with something, and it takes it back what the original function began with. Let's take another example of this. It doesn't matter what we start with. Here's our process. If I have some type of mathematical set of instructions, and it takes a 2 in, and I follow the set of instructions, and it produces a 4. The inverse, or the opposite set of instructions, should be able to take that 4 and tell me how to get back to the 2. Everyone okay with that idea? Now we've just studied composition of functions. So I'm going to represent this as a composition. We started here with the 2. We plugged it into f. And got this output, which of course represents the 4. I took that output and what did I plug it into? This set of operations. And I ended right back with the 2. So when I go through both set of instructions, I build something out of that 2. That's my original function. The inverse takes it apart, whatever I built, and sends it right back to the original parts. Does this make sense to everyone? So, if I had started from the start, you can see where we start, the process here. If I start this process and I follow this instructions and I end up with a 1 or let's make it a 12. Doesn't matter because we don't know what the process is. If I take that process and I take that output and I plug it into F, what should come out of that? I plug 12 into F. It should undo whatever this one did. So it shouldn't matter whether I start. Once I do one set of operations, the inverse is going to undo it. So, let's write down what I did. I took the value 3 and I plugged it into the function g. After plugging that value into g, it produced a 12. I don't know how. But I know if I do the set of process exactly in reverse, by plugging it into F, F should take that 3, build it into a 12 over there. 12 should dismantle it back into a 3. Again, think about any set of instructions. If I have two set of instructions that are inverse, if I give you one set of instructions that tells you how to get downtown, and the other set of instructions tells you how to go from downtown back to the Santa Fe College, if you follow both, you'll always end up where you started. You could start downtown. You're downtown Gainesville. One set of instructions gets you to Santa Fe College. The other takes you right back. So, if you go through both processes, you should always end up where you began. This is the general concept of a function and its inverse. It's undoing the process, taking you right back. Now, there are several ways we can do inverses. One thing I'd like to form is our concept of reading and writing mathematics, literacy. So I'm going to start with this idea, that this is a set of instructions. Now, this formula tells me specifically how to start with an x value and how to end with a y value. So, I'm going to write out the steps. So for function f, step 1 is you start with an input. We'll call that input x. Everyone okay with that? Now, with my order of operations, it tells me how to use this formula. If I start off with any x value, what's the very first thing I do to that x value? Anyone? So if x, for instance, is 7, what's the first step? Multiply it by 12. So I'm going to write that instruction down. Start with an x value, 2, multiply it by 12. Everyone all right? Next step in our finding y. What do we do after we multiply that value by 12? We're going to subtract 3 from that value. After I've done that, I should end up with the alpha value or the y value. Everyone okay? So we're starting with any x value. This says if you multiply it by 12 and you subtract 3, you should end with the y value. That's a set of instructions. The inverse is the exact opposite set of instructions. I've gone from here to here. Now I'm going to go back. However, it's a new set of instructions, and every set of instructions in mathematics begins with input. So I'm going to have an inverse set of instructions. I will still start with an input. But this input really represents this function's output, its y value. So with that, to go backwards, I have to undo what I just did. So, the very first thing I need to undo is what? Last thing I did to get there was subtract 3, exactly. First thing I need to do to get back is add that 3 back in. So I've got to add my 3 back. Now I'm back to here. Next thing I need to do to get back, I'm going to divide by 2. For this set of instructions, then, I should end with its output. Oh, sorry, divide by 12, yes. Thank you. Divide by 12, the exact opposite procedure. In other words, it's no different than if I say go north. If you want to go back, you gotta go south. The exact opposite step. And for this one, I will now end with its y value. I'm going to write that formula out. Notice, I've done no mathematics. I've done no calculations. All I have done is read this set of instructions. I wrote it down in pure simple English. I reversed the order. I'm now going to translate that into a mathematical formula. This new formula, I start with an x value. First thing I do is add 3 to that x value. The next thing I do is divide by 12, the full value, and that's going to let me end with my y. This is a new function. For right now, I'm just going to call this new function g of x. And that's my inverse. Next thing I'm going to do, I'm going to do the same procedure with mathematics, the mechanics. Step 1, I'm going to rewrite this function just with standard notation. So I'm taking it out of function notation and writing it in standard notation. So I really haven't done anything to it. I'm now going to give you the inverse function. The inverse function is x equals 12y minus 3. I'd like you to notice all that I have done is everywhere I saw an x, I replaced it with a y. Everywhere I saw a y, I replaced it with an x. This is my new function. This is the exact opposite procedure. But to get this in function notation, I have to solve this equation for y. Yes, sir?
12y plus 3.
Well, let's take a look at it for just a second. Very first thing I do to remove these values away from y. What's the first thing I remove? Very first thing I remove is addition and subtraction. I've got subtraction. How do I remove it? So I'm going to add 3 to both sides. Everyone good with that? So notice, over here, I'm starting on the left-hand side with an x, and I'm going to add 3 to it. To move this over, I need to add 3. Next thing I'm going to do is remove multiplication and division from y. I've got multiplication, I'm going to remove it with. So, notice. Next thing I do, divide both sides by 12. So I have my new value here, and I'm going to divide it by 12. And that's going to give me the y value of my new function. But it's not the same function as here. It's the exact opposite function, which I will temporarily display with this new symbol g of x. Notice, my mechanics produced exactly the same as reading it and reversing the set of instructions. Any questions on this?